Welcome to Module 5. In this chapter, we're going to continue with our discussion of inferential statistics, and we're also going to continue with our discussion of mean comparisons. We spent the whole Module 4 learning how to make comparisons between means. In that case, there were only two means, and in this case, we're dealing with multi-group comparisons, or two or three or more means. So the first portion of this lecture, we'll talk about the logic of analysis of variance, or ANOVA, and then we'll talk about the components of the F ratio. We'll talk about some things that we need to understand regarding multiple comparisons, and then we'll talk about a two-way analysis of variance, which involves at least two independent variables, and then at the end, we'll close out the chapter discussing the requirements of analysis of variance as a technique. Just to provide a general overview of analysis of variance, when we use analysis of variance, we want to make comparisons among three or more sample means. So this might be a situation where we're looking at an independent variable with 3 levels instead of just 2, but we could go up to 4 or maybe even 5 levels. We're going to learn how the sum of squares is affected by sample size, and we're going to learn how to control for the influence of sample size, but with the use of degrees of freedom and mean square. We're going to learn about the F ratio, which gives us kind of a degree of, it's kind of an index of between groups differences relative to within groups differences. And then the larger F ratio is going to tell us in general that we have a greater between groups mean difference than we would expect just due to sampling error. And so the larger F ratio indicates that we're going to be more likely to reject the null hypothesis in analysis of variance context. And in analysis of variance, the null hypothesis is that the means of all groups are equal. And to the extent that we have really large between group differences relative to small within group differences, we're more likely to reject that null. Now you might ask, why aren't we doing multiple t-tests instead? Why don't I just run all possible pairwise comparisons? And the idea behind this is that each time we run a statistical test, we use a significance level, as we've been talking about for a while, that 0.05. And every time we run a test, we risk that same 0.05, but it's not just additive, it's a multiplicative error. So with each mean comparison that I make, I'm risking a brand new type error, so that across multiple comparisons, my type 1 error rate is really actually quite high. In analysis of variance, I run a single test based on a single error rate that essentially divides up all of those potential comparisons within one alpha level. So the disadvantage of doing an analysis of variance is that at the end, if I reject the null hypothesis, all I know is that at least one of my groups is different, but I don't know which group is different. So because of that, we're going to learn later on in this module multiple comparison techniques that control for this type 1 error rate.